Hello everybody. Today on LeetCode, we'll be solving LeetCode hard difficulty question number 1643, kth smallest instructions. We'll be doing this in the Python programming language. In this video, I will go through the steps that I took to get to an acceptable solution. Throughout the video, if you feel like my pace is maybe a little bit too slow or too quick, feel free to skip or pause on any of the sections that you need. Let's get right into it. Bob is standing at cell 00 and he wants to reach destination row column. You can only travel right and down. You're going to help Bob by providing instructions for him to reach destination. The instructions are represented as a string where each character is either H going right or V going down. Multiple instructions will lead Bob to destination. For example, if destination is 2, 3, both HHHVV and HVHVH are valid instructions. However, Bob is very picky. Bob has a lucky number K, and he wants the kth lexicographically smallest instructions that will lead him to destination. K is 1 indexed. Given an integer array destination and integer K, return the kth lexicographically smallest instruction that will take Bob to destination. Let's look at the constraints. Row and column are upper bound by 15. Okay. K is going to be between 1 and n choose R, where n is row plus column and R is row. So before we go ahead and start working on the problem, it's important to again understand what lexicographically smallest means. In a previous problem that we encountered, we also had this term show up in the problem. If you still don't know what this term means, I recommend you going back to that problem or again Googling what this term means. So let's move on to the question now. I think it will be useful for us to jot down some notes before we go ahead and try to code things up. So let's say this is the array that Bob is trying to traverse. This is the top left corner where he starts at, and he wants to get to the bottom right corner, which is the end. Let's say this array has height n, and let's say it has width m. The final instruction string consists of h's and v's, right? And we know that the final instruction string has to be of length m plus n, right? And we also know that the final instruction string has to have exactly m h's and n v's. So let's just jot this information down real quick. Length equals m plus n. Alright. Why is this the case? Well, for him to go from here to here, while only allowed to move right and down, he has to move m rights, and he has to go n downs, right? Makes sense. When I first came across this question, what really helped me out was the example that the question gave me. Specifically looking at this list. So what is this list? This list is all the instructions of length 5 with 3 H's and 2 V's sorted in lexicographic order. HHHVV is the first one and VVHHH is the last element. Do you see anything, any patterns that is hidden within this list? Do you see anything related to the H's and V's and how they're placed and how a specific way of ordering H's and V's puts them in the order of the list? Well, let me show you what this pattern is. Let's just use that example here again. So let's say this is that list of sorted, lexicographically sorted strings, right? So what do we have? We have strings of strings with 3 H's and strings with 3 H's and 2 V's. And let's say I have a line here that splits this list into 2. What's on the left-hand side? Well, the left-hand side will be all the strings that start with H. And what's going to be on the right-hand side? Well, it's going to be the strings that start with V. How do I know how many strings are to the left? Well, what is the form of a string here? It will look something like this, correct? It's H followed by a substring consisting of 2 H's and 2 V's. So how do I calculate the number of strings here? Well, this boils down to a combinatorial statistics question, depending on where you come from. So what the number of strings that are to the left is basically just 4 choose 2, right? because, you know, there's 4 things that can change. There's 2 H's that I can do and 2 V's, so 4 choose 2. What about here? Well, strings that start with V. Again, what are the strings that look like here? Well, it's V followed by 3 H's and a single V, right? Substrings composed of this form. Again, how many strings are to the right? Well, applying what I did here, wouldn't that just be 4 choose 3? What are we trying to find in the original question? Well, we're trying to find the kth lexicographically smallest instruction. Let me just copy that here so we know exactly what we're working with. And let's box that. Okay, so remember, this list is sorted lexicographically already, right? So the kth lexicographically smallest instruction will also be the kth element in this index. That means k has to be to the left of this line or to the right. How do I know if it's to the left? Well, if k is less than or equal to the number of strings that start with h, then I know that k would have to end up in this left region, right? Otherwise, it has to end up in this right region. Do you see what I'm doing here? I'm kind of doing like a binary search of sorts. If I know it's in the left region, I don't have to look at the right region anymore. I know k is in this left region, so then I have to focus on the smaller subset, right? Do you see where I'm going at? If you still don't see where I'm going at, let me explain. So let's say that k actually ends up in the right region. It's greater than the number of strings that start with h. Then I know k has to be in this list, this sublist of the original list, right? What are the strings here? Well, like I said earlier, they all start with V and they are followed by 3 H's and 1 V in some order, right? Well, since this list is already lexicographically sorted and all the strings start with V's, what I can do is I can essentially ignore the V, and this list will still be lexicographically sorted, right? Again, I'm going to do the same thing that I did here with the line. I'm going to draw a line down somewhere in this list. This line will divide this list into 2. Strings here are strings that start with H, and here are the strings that start with V. Again, you see where I'm going at now? I'm working on a smaller subproblem. Every time I know if k is to the left or the right, I move to a smaller region. So now, what has the problem become? Instead of finding the kth element in this list, I'm finding the k minus, let's say, okay, let's use a variable here instead of, so we don't get confused. Let's say k minus a string in this list. What is a? A is just the number of strings that start with h here in the original left region. So let me just write that down. Now you can see the pattern, right? I can essentially construct my final solution. I can construct my final solution one by one by searching if k is to the left or the right. If it's to the left, then I know I have to add h to my final string. If it's to the right, I add v to my final string. Let's code this up. Okay, so let's have 2 variables, m and n. This corresponds to, you know, the width and the height. What would m be? Well, let's see here. Destination 0 corresponds to the number of v's. The number of v's corresponds to the height, so that should be destination 0, index 0, and then my m would be destination 1. We said earlier that the total number of characters in the string is m plus n, right? And we know that the total h's possible that we have to have in our final string is equal to m. The total v's will be equal to n. So the way, like I said earlier, the way I'm going to construct my final solution string is I iteratively add one character, one at a time. So I start with the empty string, and I basically just iterate total times. So while total is not equal to 0, I have to do some stuff. What I do? Well, it's that line drawing, right? I compute how many things are to the left, and I check to see if k is greater to the number of things to the left. How do I compute the number of things to the left? Well, I have to use this mathematical formula, the combinations, right? N choose R. The N choose R function can be called with n.com, and what is N? N is total. And what is R in this case? Well, if I pick, what does it mean to be in the left hand side? I pick an H, right? So the R would be total H's minus how many H's that I have currently in my string, minus 1. So this makes me, I have to keep track of the number of H's that I have and the number of V's that are currently in my solution string. Okay, so after doing this, computing left, I check to see if k is greater to the left. If it's greater than left, then I know I'm in the right region, right? So what do? I add 1. I know there's 1 extra V in my current string. I add that V to my string. And remember here, the subproblem changes. Oopsies. The subproblem changes when I traverse left or right. So I need to make sure that I update my k. So k minus equal left, which is the number of things to the left. Otherwise, I know I'm in the left region. So what is that? That is just simply equal to current. I just need to update my number of h's, update my solution, and that's it. And at the very end, what I need to do is just return solution. Okay, the problem is this is not going to work. You'll see what's wrong in a bit. There's a small caveat. Okay, apart from that, that is the syntax error. There's a small caveat that you may, okay. See here, value error k must be a non-negative integer. What this means is this value here, total h's minus cur h's minus 1 may be less than 0. So what is the case when total h's minus cur h's is equal to 0? Well, that is the case when we draw this line down the list. There is literally nothing to the left. There are 0 strings that start with H. So we have to go to the right, right? We have to pick V. So we just simply do this. And this will ensure us that we always pick V if there are no more H's to pick. And now I believe the solution will work. And it should work because I already did this before. So let's see. Okay, and it does work. So let's analyze the runtime of the solution. Since m and n are both constants, right? Well, yes, they are constants. They are less than equal to 15, in fact, as per here. This whole while loop takes a constant number of iterations. And all the operations I do here, but this math.com operation, are all constant operations. So it all boils down to how fast this operation will finish. I'm not sure exactly how math.com runs, how fast it runs, but at the end, the runtime of this whole solution would just be equal to the runtime of math.com. Okay, and that's it for today. This is the second problem that I will go through in a series of LeetCode problems. I'm just, this is still a pretty new series that I'm trying to do, and I'm open to any, suggestions or critiques that, since I don't know how well I'm conveying my thoughts, if there's anything that you think that I should change, let me know down below. Leave a like, comment, or subscribe. And as a wise man once said, a LeetCode problem a day keeps unemployment at bay.